Hello. All right, welcome. So now we're going to be looking at a very important topic. Okay, it's also type of polynomials, and it is called binomial expression, right? So now a binomial expression is a polynomial made up of two terms. Okay, remember, a polynomial is made up of variables, constant, and of course coefficient. Okay, in many terms. Or for example, a binomial can start with just let's say x plus y. Okay, it can uh, also be x. Okay, plus 2xy plus y square. Okay, now this is actually a binomial. Why? Because it is made up of two terms. Okay, now the binomials can also increase in terms. Okay, it can increase in power, right? Just like we have s plus y raised to power 1. Okay, we can also have x plus y raised to the power of 2. All right, we can also have x plus y raised to the power of 3. Okay, so these are different powers of a binomials. Okay, as you will keep on increasing, and of course when you expand it, okay, we are going to definitely it will be converted into a polynomials, right? Okay, now you have x plus y. If you expand this, it will still be s plus. When you expand this, you have s square. Okay, you have s square plus 2xy then plus y square. All right, try expanding that, and of course when you expand this, now as you can see, the two terms, the one that has two terms raised to power 1 is actually is giving us two terms polynomials. The one that is raised to power 2 is giving us three terms polynomial. So as it increases, the number of terms increases. Okay, the one that is raised to power of 3 will give us four terms polynomial, and that is the fourth term include s raised to power 3 plus 3x square 3s square y plus 3x y square, then of course y cube. Okay, so now this is the expansion of polynomials. Okay, I can go on, okay, and on to actually look at higher powers of the polynomials, right? But the question is, how do we actually expand this, especially when the power, okay, is high as let's say more than 3 or even 3. Okay, because we are very much familiar on how to expand rest the power of 2. Okay, how do we expand it if as the power goes higher? All right, so we are going to look at laws. We are going to look at principles, okay, or method which can easily help us to actually expand this. Okay, so now the principle that will help us to expand this actually will, one of it, okay, is called Pascal triangle. Okay, one principle we utilizes Pascal triangle. Okay, as you can see, as we keep on expanding, as we go, okay, higher in a higher power, okay, this expression increases, okay, in a triangular form. Like at the very first instance, the coefficient of xy is 1 1. Okay, then it increases to 1 2, excuse me, 1 2 1. That's 3 times now. Then it also increases again to 1 3. I'm looking at the coefficient now. 3, then 1. 1, 3, 1, 3, 3, 1, okay? 1, 3, 3, 1. So as you can see, in form of a triangle, all right? That's how it's increasing. Okay, so while this is the coefficient, while the powers of the variable is, okay, s is increasing. As s increases, no, sorry, s is reducing, okay, s reducing, and the y is increasing, because s started with the highest power, which is 3 in this case, okay. Now came to this place, s started with the highest power, 3, came to this place, while y here is 0. That is why y here is y raised to power 0. That's why it's 1. We don't have y here. Then s reduces to the power of 2. Then y increases to the power of 1. Okay, s reduces to the power of 1, y increases to the power of 2, s reduces to the power of 0. That is why it's 1 here. I can't see it. Then y now increases to the highest power. Okay, so having known that, now we can actually use Pascal triangle, okay, to get any power of polynomial that we want. Okay, we can use it now. For example, first of all, let's see how it works. Okay, now let's say I want to get the one of raised to the power of 4. Okay, how do I actually get this coefficient? That's the next thing. I've told you how the powers of the variable increases and reduces. How about the coefficient? How do we come about this coefficient? All right, now let's see how come about the coefficient. To get the next coefficient, okay, we get it from the addition of the previous coefficient. For example, now this is 1 1. For me to get the one of s plus y raised to power 2, okay, how do I actually do that? I will add, okay, the middle term 1 plus 1, that is 2. Remember the last term, okay, the last term at the extreme end, it should always be 1 1. Okay, so I write 1 1 and I add this 1 plus 1, it gives me 2. Then for how do I get this the degree 3, power 3? Okay, I'll write the last term, which is of course 1 1. Then I start adding this. I have 1 plus 2, this gives me 3, and 2 plus 1. So always add. For me to get the middle coefficient, I always add the previous midterm. Okay, so which simply means that if I want to get the coefficient of 4, the coefficient of degree 4, okay, I will first of all write down my 1 1, the extreme coefficient is always 1. Then I start adding 1 plus 3 here. For this is 4, this middle is 4. Then 3 plus 3, this is 6. Then 3 plus 1, and this is 4. All right, so that is how it works. Now, how do I actually apply my coefficient? Apply the variable, okay, s and y. All right, now let me use this to illustrate. For this, remember s is actually reducing. Okay, so s first will have the highest power. The highest power here for 4 is s raised to power 4, and the y is y raised to power 0. Okay, so let me just write that down, y raised to power 0. Then I bring plus. All right, don't forget the coefficient is 1. Then the coefficient here is 4. Then x reduces to, now s was 4, s reduces to 3. Then y increases by 1, y raised to power 1, okay, which is something as y, plus the next coefficient is 6. All right, 6. Then x now is reducing to 2. Then y will increase to 2. All right, then plus the next coefficient is 4. This time around, s reduces to 1, y increases to 3. Okay, now y, the last but not the least, the next coefficient is 1. Okay, and of course at that point, x have reduced now to 0, while y now increases to 4. Okay, so now you remember, you know that any number or any expression raised to the power of 0 is always 1. So this should be 1. 1 times s raised to the power 4. So what I'm having here is s raised to the power 4 plus 4x raised to the power of 3 y plus 6x square y square, then plus 4x y cube. Then of course x raised to the power 0 there is 1, so I am left with y raised to the power 4. So this is how we apply Pascal triangle in expansion. Okay, you can also do for degree, the one of degree 5. Okay, I can try that for degree 5. Let's look at how degree 5 will work. Let's get the coefficient first. Okay, for degree 5, what I'm looking at as, I mean x raised to the power y raised to the power 5. Okay, so let's get the coefficient. First of all, we'll write the last term 1 1. Okay, so we'll get the middle terms by adding 1 plus 4, that is 5. Okay, 4 plus 6, that is 10. 6 plus 4, that's another 10. All right, no need for me to be putting the plus, right? Let's no need for me to be putting the plus. Okay, so let's go there. As I said, 1 plus 4, that is 5. 4 plus 6, that is 10. In between here, 6 plus 4, in between it is 10. Then 4 plus 5, in between it, that's 5. Okay, so you can go by putting the variable, that's x raised to the power 5. Of course, y raised to the power 0. Then plus 5. S now reduced to 4. Y increased to 1. Plus 10. X reduced to 3. Y increases to 2. Plus 10 again. X reduces to 2. Y increases to 3. Okay, then plus what do we have, 5, right? 5. X reduces to 1. Y increases to 4. Then plus the last but not the least, okay, x reduces to 0. Y increases to 5. Okay, so if you do that, of course you arrive, just for us to change it, that's gonna be x raised to the power 5. Y raised to the power 0 is 1, so we are done with that. So here we go. It's still gonna be the same thing. 3x 10x raised to the power 3 y squared plus 10x square y raised to the power 3, then plus 5x y raised to the power 4, then plus y raised to the power, x raised to the power 0 is 1, so I have y raised to the power 5. Alright, so that's how Pascal triangle works. But now, Pascal triangle has limitation. The reason why I say it has limitation is that you need to draw the triangle to get to the particular degree you wish to expand before you can expand. Okay, what if the degree or the power of the binomial is 20? That means you have to draw your Pascal triangle till you get to 20, which is not ideal. Okay, so we are going to look at another method of binomial expansion, right? Which of course is the general formula, okay, of binomial expansion, and I'm gonna give you the formula. Okay, now the general formula of binomial expansion actually uses combination, right? So if I have x plus y raised to power n, okay, n can be any number, right? So the expansion is gotten by actually summing the series of starting from the upper limit of n, okay? Then the lower limit, I use r to represent the lower limit, okay? The lower limit, which of course r, which start from 0, okay? So, and of course, in form of combination, n combination r. I will explain all this so that you understand what I mean. Then s raised power, remember, n minus r, then y raised power r, okay? So don't forget that r start from 0, okay? So now let's actually, I'm going to use example to, I'll use it to illustrate this. Don't forget this represents summation, okay? So that means we are adding. All right, so now let's say, let's use, let's just do x plus y raised to the power of 3. Let's start with this. All right, now the n, okay, is 3. The r will always start from 0. The n, okay, the n, okay, is always constant. You understand? The n is the highest power, that's 3. While the r start from 0 and increases to it gets to 3, okay? So let's start. So what I'm gonna have is n, which is 3 combination. 3 combination. I'll start from 0. Are you okay? So that'll be 3 combination 0. I will tell you how to do combination and permutation, but let's write down the formula. Okay, there are now write x, okay, raised to the power of course the n is 3 minus r start from 0, so that's going to be 3 minus 0. Then of course y is being raised to the power of r, okay, which is 0. Remember, it's summation, okay? It keep on increasing. R, the sum, they call it summation, okay? I will do the sum plus this time around. Remember, r is equal to 0. Then when r will increase to 1, okay, till r get to 4. And of course, still gonna give me 3 combination. This time around, r have increases to 1, okay? Then of course, x is going to be, remember, it's n minus r, that's 3 this time around minus 1. Y has increased to 1. Then of course the next r now is 2, so that's going to be 3 combination 2. X, you know what it is, that is going to be 3 minus 2. Then y raised to the power 2. Y is always raised to the power of the r, okay? I bring plus here. Do the next. I have to remember, I will do it till I get till my r is equal to 4, is equal to 3, okay? So I think this is the last part. All right, so I'm gonna have 3 combination 3. Of course, x raised to the power of 3 minus 3. Then y raised to the power of 3. Okay, so with what we have, we can evaluate. So let's simplify. Okay, so I have 3 combinations 0, 3 combination 0. So I'm going to show you combination if you don't know that already, how to evaluate combination, okay? Okay, n combination r is always given by the formula n factorial divided by n minus r factorial times r factorial. Okay, what is factorial? All right, now let me use example to illustrate. For example, you have been given something like, let's say 6 combination 3. The n there is 6, okay, the r there is 3, so that's going to be 6 factorial. 6 factorial divided by 6, remember, is n minus r factorial. 6 minus 3 factorial, okay, you get to know what factorial is. Then I now multiply it by the r factorial. Of course, the r is 3 factorial. All right, so now this is gonna be equal to 6 factorial, right? Then of course 6 minus 3 factorial, that gives me 3 factorial, right? Then times 3 factorial. So now what is factorial? Factorial is actually, okay, successive multiplication of numbers, okay, or decreasing order, okay, of so of successive multiplication of number t gets to 1. Let me tell you what 6 factorial is simply 6 times 5 times 4 times 3 times 2 times 1, okay, to the end. But I'm not going to actually multiply 6 factorial to the end. I'll stop at 3 to make my uh, calculation very easy. Why? Because I'll stop at 3 factorial. I'll just stop at 3 factorial because the denominator has 3 factorial so that it can easily cancel out to make my calculation very easy. So I have 3 factorial times 3 factorial. Okay, so that 3 factorial cancel 3 factorial. So I have 6 times 5 times 4. All right, and of course 3 factorial is 3 times 2 times 1. All right, so if I do this using a calculator, of course you know what that should give. Okay, so you can use calculator. I'm just using this to illustrate what factorial is so that it will enable you to understand what we are going to be doing there. So I will clean it up. Okay, so let me clean up. All right, here we go. All right, so let's now do our work. All right, so this is gonna be equal to, you know what it is. Okay, so 3 factorial 3 factorial divided by 3 minus 0 factorial, then times 0 factorial. Okay, so how does that work? Then of course times multiply by now x raised to power 3 minus 0, x raised to power 3 minus 0 is 3, then y raised to power of 0. Okay, of course y raised to power 0 is 1, so I don't need to write that down. Plus I go to the next. The next is 3 combination 1, that is 3 factorial divided by 3 minus 1 factorial, then times 1 factorial times 1 factorial. All right, then of course that will be now x raised to power 3 minus 1, that is 2, y raised to power 1, which is y, plus the next is 3 combination to 3 factorial divided by 3 minus 2 factorial, then times 2 factorial, right? At this point we'll have x, okay, raised to the power of 1, okay, then y raised to the power of 2. Okay, the last but not the least, I have 3 combination 3, so I have 3 factorial divided by 3 minus 3 factorial, right? Then times 3 factorial, which of course we have s raised to the power of 0, which of course is 1. Okay, I don't need to write that down. And then y raised to the power 3. Okay, so now let's evaluate our factorial. Okay, 3 minus 0 factorial. Okay, now 0 factorial is 1. Okay, so I'm left with 3 minus 0 factorial, right? So 3 minus 0 factorial will give me 3 factorial. Please take note of this. 0 factorial is 1. 0 factorial is not 0, okay? 0 factorial is 1. So 3 factorial divided by 3 minus 0 factorial. 3 minus 0 factorial is still 3 factorial. 2. 3 factorial cancels 3 factorial. So I have 1. So that is why at this point I'm having x raised to the power 3. Okay? Then plus the next term, right? I have 3 factorial, 3 minus 2 factorial, okay? 1 factorial is still 1, right? So now 3 minus 2 factorial will give me 2 factorial. So I'm going to just do 3 times 2 factorial. Or no need of me actually working that out. If I do 3 times 2 factorial, so that would be 2 factorial cancel 2 factorial, okay? I'm just left with 3, okay? So that you understand what I'll make the work easy. 2 factorial here, 3 times 2 factorial, 2 factorial cancel 2 factorial, I'm left with 3. So I have 3s squared y. Okay, let's see how it works here. Okay, 3 factorial, 2 factorial. 3 minus 2 factorial, that's 1 factorial, which is something as 1, okay? And of course, 3 factorial, 2 factorial, that's 3 times 2 factorial. 2 factorial cancel 2 factorial. So I'm still left with 3 x raised 3s, then y raised power of 2. Then the last but not the least, I have 3 factorial divided by 3 minus 3 factorial is 0. 0 factorial, which is 1, okay? And of course, 3 factorial divided 3 factorial have 1. So I have 1y, okay? 1y raised to the power of 3. So as you can see, this is the same with what we did with Pascal triangle, okay? So this is more convenient, especially when the order, okay, when the power of the binomial is large. Because if you want to, let's say the power of the binomial is even up to 50, okay, you can use, before you use Pascal triangle to get to 50, you must have filled the whole page, okay? It is very necessary for you to know how to actually use this, okay? So now we are going to look at example question, okay, where this is actually being, where this is applicable. All right, I will clean up. Okay, so now the question goes like this, okay? It says, find the system of, find the sixth term of the expansion, of course, 4a minus b square then all raised to the power of 10. All right, so I hope that is well understood, okay? So now we are asked this, you are not asked to expand, but you're only asked to find the sixth term. All right, so remember, if we're expanding, okay, what is increasing is r. Remember the formula, okay? Summation of n, upper limit r, lower limit that start from 0, okay, x raised to the power of n minus r, then y raised to the power of r. Okay, so we simply mean, okay, the combination, I've not added the combination, please pardon me. Okay, the summation of the combination first before I put the combination of any combination r, please pardon me. All right, so which simply means that if I am to find the system, okay, remember r start from 0, okay? The first time r is 0, Second term, r is 1. Third term, r is 2. Fourth term, r is 3. Fifth term, r is equal to 4. Okay, while the sixth term, r is equal to 5. So you can discover that any term, r is always 1 less than that term. Okay, so if you are being asked to find the 10th term, r is 9. If you are being asked to find the 8th term, r is 7. Okay, so you know the formula how we do that. So that will be, since r is 5, okay, and of course the power, the power is 10, right? So that means what you're looking at here is what? 10 combination r, okay, which is 5. Then of course s, what represents s now is 4a. Don't, please take note, what represents s there is 4a, so I put it in the bracket 4a. Okay, raised to the power of n minus r, that is raised to the power of 10 minus 5. Then what represents y is b square. Okay, then times that b square, don't forget that you have to include the minus. Okay, minus b square, right? Minus b square, then raised to the power of r, which is 5. Okay, raised to the power of r, which is 5. Okay, so we know how we do our combination. That is 10 factorial divided by 10 minus 5 factorial, then times 5 factorial. Okay, all right, times, what do we have next? Okay, all right, so that would be 4a all raised to the power of 10 minus 5, that is 5, then times minus b raised to the power of minus b squared raised to the power of 5. Of course, in this is 5 will multiply 2. Okay, so I'm gonna have minus b, all right, raised to the power of 10 minus b raised to the power of 10. Okay, so I hope that is well understood. Okay, so let's evaluate our factorial. All right, let's evaluate our factorial. Excuse me. Okay, here we go. So of course you know how we do it. All right, this is gonna be equal to 10 factorial. Okay, 10 factorial. Now I have 10 minus 5 factorial. Okay, so I also have 5 factorial, so I'm gonna do my factorial. That was 10 times 9. Don't forget, I will stop at 5 factorial so that it will cancel out. 10 times 9 times 8 times 7 times 6, then times 5 factorial divided by, of course, 5 factorial times 5 factorial. All right, don't forget to add our variables. Okay, of course, 4 raised to the power of 5. Calculator will help us to do 4 4 raised to the power of 5. Okay, what is it really? Let's work with calculator. Okay, 4 raised to the power of 5. Do I have okay, let me get scientific, right? So 4 raised to the power of 5. What do we have? Okay, I have 1 0 10 24. All right, I have 10 24, so that's gonna be 10 24 times, don't forget the times, let me put dot, 10 24. Okay, 10 24. Then of course a raised to the power of 5. Then of course uh minus b raised to the power of 10. Okay, remember 10 is an even number. Okay, so it will definitely cancel this minus. You understand? If it's an even number, minus times minus is plus. Okay, so that will give me b raised to the power of 10. Okay, so now let's do our cancellation. Remember, 5 factorial will definitely cancel 5 factorial. All right, so that we now have we'll do a multiplication. 10 times 9 times 8 times 7 times 6. Let's do that. 10 times 9 times 7 times 6. Okay, that is giving me 3780. 3780. Then divided by 5 times 4 times 3 times 2. That's 120 divided by 120. All right, then times 1024. 1024. Okay, a raised to the power of 5, b raised to the power of 10. All right, so I have 3780 divided by 120. All right, then times 1024. 1024. Okay, 1024. All right. Okay, hope I'm not mistaken. Okay, so I have 322. It's H8 approximately. So 32288. Then a raised to the power of 4, b raised to the power of 10. Okay, so I hope I'm not mistaken with the calculation, but that is the principle, okay, that is behind that evaluation. All right, so yeah, I'm not mistaken. Okay, so that is my final answer. All right, that is my final answer. So as you can see, with the binomial expansion, using the general formula of binomial expansion, I can actually get any term, okay, applying this principle. All right, I think so far so good. We've been able to establish the relationship, okay, that exists between Pascal triangle, okay, of expanding binomial and normal binomial theorem or formula of expansion. Okay, so let's look at, we are going to, in the next video, we are going to look at questions. Okay, we are going to apply everything we've learned. Okay, we're going to apply them to solve examination question. All right, see you in the next video. Thank you very much. Hello. All right, welcome. So now we're going to be looking at a very important topic. Okay, it's also type of polynomials, and it is called binomial expression, right? So now a binomial expression is a polynomial made up of two terms. Okay, remember a polynomial is made up of variables, constant, and of course